In physics, the definition for work is force times distance. And since force is in pounds and distance is in feet normally, we would say the unit of work would be the foot-pound, which is a great formula if the direction of travel is in one direction, like horizontally. But what if the force being applied on an object to move it is being done at an angle to the horizontal? Then we're dealing in vectors. So we say that the work, which is a scalar quantity, is the force vector times the distance vector. A force is given by the vector 2, 3 and moves an object from the point 1, 3 to the point 5, 9. Find the work done. So in order to find the work, I need to know the force vector and the distance vector. I don't know the distance vector though, but they did tell me the initial point and the terminal point. So if you know the initial and terminal point, you can find the vector by doing terminal minus initial of the x's, terminal minus initial of the y's. So the distance vector must be 4, 6. Now I can find the work done by doing the force vector times the distance vector, by doing the dot product. So 2, 3 dot 4, 6 is going to be 2 times 4 plus 3 times 6. 8 plus 18 is 26. And the unit of measurement is the foot-pound. A man pulls a wagon horizontally by exerting a force of 20 pounds on the handle. If the handle makes an angle of 60 degrees with the horizontal, find the work done in moving the wagon 100 feet. I'm going to start by drawing a picture. So here's the wagon, and then there's this handle. The handle makes an angle of 60 degrees with the horizontal. He's going to move the wagon 100 feet this direction. And the force being applied, the magnitude of the force being applied on the handle is 20 pounds. So in order to find the work being done, I need to know two things. I need to know the force vector, I need to know the distance vector. The distance vector is the easy one. The distance is only moving horizontally. So we're going to say that the distance vector is 100i. Or you can say that it's 100, 0 as a vector. Either case, I don't care. However, the force on the handle has an angle associated with it. So to find the force on the handle, we have to do 20 times the cosine of 60 degrees for the horizontal component, and 20 times the sine of 60 for the vertical component. Remember, this only applies if there is an angle to the horizontal with the force being applied. So now I'm going to simplify. 20 times the cosine of 60 degrees is going to be 10. 20 times the sine of 60 degrees is going to be 10 the square root of 3. And in order to find the work now, I can do force, dot product, distance. When I do that, I'm going to get 10 times 100, which is 1,000, plus 10 to the square root of 3 times 0 is 0. So it turns out the work being done is 1,000 foot-pound. And that is an application of the dot product.